Saravanan sir, please go ahead.
Oh, okay, sir. A very good evening to one and all, especially ma'am Radhika ma'am, Dr. Radhika ma'am. Please ma'am, just
Good evening, sir.
participants will be joining ma'am. Good evening ma'am. Anyway ma'am, we will start now. Almost 60 to 70 participants came, so they will join as soon ma'am.
Okay, sir.
Okay. Anyway, thanks to Atal sponsored faculty development program in the title of Next Generation Green Energy Powered Electrical Vehicle and Renewable Energy Integration using Solar Microgrids. Now we are in the third day. Successfully, we are completed 5 sessions and we are entering into the 6th sessions with your great supports. Next. Now, I am happy to welcome Dr. Radhika Dora, working as a professor and head of the department in Gitanjali Institute of Technology. Madam is completed BTech from JNTU Anantapur and MTech from JNTU Hyderabad and PhD from JNTU Hyderabad. Madam is completed more than 20 international and national papers. Madam is having 24 years of pure academic experience in the role of lecturer, senior lecturer, assistant professor, associate professor, now professor and head of the departments. The research area of interest, power quality problems and mitigation, renewable energy generation and electric vehicle design. Ma'am, please take the session, ma'am.
Yes, sir. Thank you so much, sir, for your introduction. Let me thank first of all Atal for giving me this opportunity to be a resource person for delivering a lecture on hydrogen energy generation and storage challenges. And can I share my screen, sir, now?
Yes, ma'am.
Okay, sir.
I think permission already given, ma'am. 1 second. Sir.
Yes, given. You can stand, ma'am, please.
Yeah. I'm not able to, sir. That's why I'm asking whether permission is given to me or not.
Yes, ma'am.
Okay, it's coming, sir.
Okay, ma'am.
Right. At the same time, I would like to thank Holy Mary Institute of Technology and Science for giving me this opportunity, being a resource person for the Atal sponsored FDP. Thank you, sir. Thank you to Shivaganeshan sir as well as Saravanan sir for identifying me as a resource person.
With our pleasure, ma'am. Please.
Thank you, sir. Thank you. Right. Today, I just want to give a brief idea about what is hydrogen energy production and how we can store this hydrogen energy, as well as what are the challenges involved in this hydrogen energy production and storage. Let me start with my presentation goes with the introduction towards the hydrogen energy and why especially we are moving towards hydrogen and what is the concept of green hydrogen, and then how many ways we can generate the hydrogen energy, as well as what are the challenges involved in it, as well as what are the storage methods we are having, and what are the challenges again in the storage. And finally, I want to conclude what exactly hydrogen energy generation is. I just want to start my presentation with a question like, what does development of a country mean? Can anybody tell me what could be the meaning of development of any country? Anybody?
Keep on increasing, sir, in all the aspects.
Yes, of course. It is one way of answering. So any development, it may be in the economic aspects, or it may be in social development or cultural transformation, whatever it could be. But ultimately, to achieve all these particular developments, the main concept, what we have to concentrate on is environmental protection. Indirectly or directly, this environmental protection plays an important role for the development of any country. I strongly believe in this. Now, again, is India a developed country? You may be having a doubt why I'm moving to developments, because my topic is, you are thinking that it is hydrogen generation, but there is a lot of correlation we have between the hydrogen energy generation and development of the entire nation. So if we see the statistics, so how many developed countries and developing countries are there in the entire globe? So India is still a newly industrialized category it is in. Whereas if you see the other USA and all, Australia, these are all the developed countries we are having. Now India is just moved forward from developing countries to newly industrialized country. So if you go again the statistics, if you see here in this particular graph, the violet color, the purple color, which is indicating India is just started its industrialization. It is after 2000, right? So we are, in the beginning, we were under least developed country. Later we moved to developing. Now we are in the sector of newly industrialized country, but our Prime Minister Narendra Modi's main aim is to be, our country need to be in this developed country area. So now how we can go, we can move forward to the developed countries. For that, we need to think of again some goals which are set, or which will decide whether we need to be in a developed region or still developing country. So the Millennium Development Goals, have you heard about this or not? I don't know. So the United Nations, which is formed by 51 countries after the Second World War, they decided some goals so that it can decide whether the country is in what area, like whether it is a developed country or it is in developing area. So this Millennium Development Goals are likely, we have 7 development goals given over here, sorry, 8. And in this, if you have a look on this, the ensure environmental sustainability. This is the main criteria we have to focus on, because this will either directly or indirectly impacts the all other goals which are set here. Right? You can see this particular figure which is presented over here. Now, this goals were actually set in 2015, right? Now, this Millennium Development Goals, based whether they have achieved these particular goals, how many goals were achieved by a country, that country will be decided whether it is a developed country or still developing country. So now, after 2020, one second. So here we have this Millennium Development Goals superseded with Sustainable Development Goals. So the Sustainable Development Goals are again 17 goals, right? So these are the 17 Sustainable Development Goals which are decided by, again, the United Nations. Our India is a founding member of that United Nations, and they have signed the UN Charter in San Francisco on June 26, 1945, actually. So from—
Madam, your PPT is not visible. Someone else is presenting.
Yes.
The presentation is not visible, ma'am. Some participant has unknowingly presenting the screen, it seems.
I request the participants to please stop your sharing screen. Is it visible, sir, now?
Not yet,
Is
ma'am.
my screen visible?
No, ma'am. Sunita Sweety is presenting.
Someone is presenting.
Sharvanan, sir.
Just a minute, ma'am. I will look it.
Again, I'm sharing the screen.
Ma'am, just a moment, ma'am. Just a moment.
Okay, okay.
Ma'am, Sunita Sweety, ma'am, please.
We removed, please.
Ah.
Sorry, ma'am. Sorry for the inconvenience.
It's okay, sir. Can I share now?
Please, ma'am.
Is it visible, sir?
Visible only. Ma'am.
Yes, ma'am.
Okay.
Please go ahead.
Yeah. So if you see again this 17 sustainable goals which were decided by United Nations, again, the main criteria which we have to, the main goal which we have to concentrate in this is again the climate action. The 13th goal plays an important role over here. So this 13th goal, climate action, why we need to consider that as a main goal? Because if you check the worldwide carbon emissions, which is indeed changing the climatic conditions, which indeed changing so many other factors of any country's development, is just have a look over here, the cumulative energy related CO2 emissions and emission gaps. If the same transportation system, energy generation system, if we are using what we are using currently now, if we follow the same, by the end of 2050, the carbon emissions will be 1600 gigatons. So it will be a huge development of carbon dioxide, so which will damage the human life, all living beings which are there on Earth. So that's why we need to think of that particular climatic action as a main goal. And at the same time, the annual CO2 emissions, if you see the countrywide, China is having 10 billion tons of carbon dioxide emissions, and India is in 3rd place. So that is the reason why our Prime Minister Narendra Modi sir has decided to have this carbon emission, zero carbon emission by the year of 2047. So now at the same time, how we can reduce this particular carbon emissions, if you have a look on it. So whatever the current systems we are using for the transportation or power generation or industries, whatever we have, if you see on the left-hand side over here, the present conventional systems, whatever we are using, if we use continuously, then the rate of carbon emissions will be very high by the end of 2050. Whereas if you make use of this renewable energy generation and usage of this renewable energy everywhere, starting from construction to the industries, then there is a chance of reduction of 70% carbon emissions by the end of 2050. So that is the reason why I'm considering this climatic action as the main goal, which is to be achieved by every country so that it can fall into the category of developed countries. And there is also an agreement, because simply if we say we are trying to achieve this carbon dioxide emissions and all, nobody will be strict to that. So that's why there is an agreement called Paris Agreement was made. And this Paris Agreement stating that it's an international treaty on climate change signed in 2016. And the treaty covers climate change mitigation, adaptation, and finance. And it is agreed by 196 countries. And what it is saying is exactly, we need to reduce the temperature of the globe by 1.5 degrees Celsius every year. For that, what is the main thing we have to do is we need to reduce the carbon dioxide emission. So if the carbon dioxide emission is reduced, automatically there are a lot of changes going to come on the globe. So at the same time, I just wanted to show you the results of CCPI. This is Climate Change Performance Index. So this says that India is at a very danger zone. See, green indicates it is at high level. That is the climate change. Every year by year, if you think, this climate change is very fast in our India because of the carbon dioxide emissions. Not only in our country, few other countries are also there along with us, but we need to bother about our own country. So now, how this particular hydrogen generation is linked to this particular UN SDGs. If we are able to generate hydrogen and utilize it in so many areas, then we can achieve the goals which are listed over here. So the climatic action, so definitely we can change the climatic conditions. We can reduce the temperature with the less carbon dioxide emissions. And at the same time, we can have clean energy, or affordable clean energy, as well as we will be having clean water, and we have decent work and economic growth. And at the same time, industry, innovation, and infrastructure will also increase. Why? Because what are the techniques we need to develop to have more hydrogen generation as well as utilization. It will indirectly lead to this particular innovations and industry infrastructure developments. And at the same time, if the climate is changed, the crops, whatever we are having, that may be in a better manner. So we can reduce the hunger also. The hunger percent also can be reduced. So what are the direct impact we have on what UN SDGs and indirect impact on what UN SDGs we are having because of the generation and utilization of this particular hydrogen? I just gave a glance over here. So these are the 7, 12, 17, and 1. These are the direct impact along with the 13. 13 is the main one. And indirect impact will be there.
Ma'am, excuse me, ma'am.
Yes.
Some slides are not moving, ma'am.
Why, sir? For me, it is changing.
The slide, 6th slide is on the screen, ma'am. Please share the entire screen, ma'am. I think you have shared the window.
Yeah, okay, sir. Okay.
Now it will be moving.
Maybe there is a lag, sir, between you and me. So that's why it's not. Anyhow, I'm sharing the entire screen then. Is it okay for you now? Excuse me?
Yes, ma'am.
Ma'am, make it, yeah, that one, ma'am. Yes, ma'am.
Yeah, right. So now hydrogen can help achieving these particular SDGs, what I wanted to project here. And why only hydrogen? Why not the other fuels we are having? Because hydrogen is a promising energy source for the decarbonizing the energy system and reducing climate change. This is the main reason why we are talking about hydrogen today. Now, what is hydrogen? Maybe this is a simple question. You all know what exactly hydrogen. Hydrogen is the first element of our periodic table, and it is the lightest and most abundant chemical element typically found in molecular form, and it is colorless, odorless, and highly inflammable. And also, it is a clean alternative to methane. As of now, we are using methane everywhere for our domestic purposes to industrial purpose, but hydrogen is a clean alternative to that particular methane, which is available in the form of natural gas. And this hydrogen is available 75% on the mass, if you consider the entire universe. And here on Earth, vast numbers of hydrogen atoms are contained everywhere in water, plants, animals, everywhere we are having this. That is the reason why now the trend has moved towards the hydrogen. The topic of hydrogen is very hot today now. Now, when natural gas is burnt, actually, presently what we are using, it provides heat energy, but a waste product alongside water is carbon dioxide, which when released into the atmosphere contributes to climate change. Whereas burning hydrogen does not release that particular carbon dioxide. Again, we can make use of this particular hydrogen as fuel also. That is the reason why the entire world is thinking of how we can generate this particular hydrogen efficiently and how we can store this particular hydrogen. These are the two main hot topics currently happening. Because hydrogen can be used as a fuel cell, where hydrogen fuel cells combines hydrogen and oxygen in an electrochemical process to produce electricity. That means we can make use for our electric vehicles and industries, in household, everywhere we can use this particular fuel cells. And this can be used as heating, where we have industrial applications with heating. There also hydrogen can be burnt. Huge energy can be released if we burn this particular hydrogen, because hydrogen efficient density is very energy efficient density is more for this particular hydrogen. And we can go for this particular hydrogen for electricity generation also. And we can make use of the hydrogen transportation. And we can store this particular hydrogen in fuel cells, and we can use for emergency power. And this can be easily transported to remote locations where power cannot be generated or generation cannot reach to remote areas. That is the reason why we are thinking of this particular hydrogen. Now, why only hydrogen? There is a justification given over here. Why only hydrogen? Because hydrogen is energy efficient. A gaseous hydrogen contains nearly 3 times more energy per unit mass than gasoline. So if I take one bottle of petrol and one bottle of this hydrogen gas, maybe with that volume, the hydrogen efficiency may be less. But if I take per mass, per kg hydrogen, if I take kg petrol, then hydrogen is giving more energy efficiency. So that is the reason why we are thinking of this particular energy efficiency. And it, as I already told you, there are 0 emissions we will be having if we make use of this particular hydrogen. And we can have fast charging and long usage. So the current technique what we are using for charging of our electric vehicles, if it takes 30 to several hours, whereas it can be reduced in, if you make use of hydrogen fuel cells, we can charge the vehicles just in 5 minutes. So it is a fast charging, and also it can be used for longer durations also. This is another reason why we are thinking of this particular hydrogen fuel cells. And also versatile, it can be used, it is more, we can move it from anywhere to anywhere, and transportation can be done through pipelines as well as tube trailers. And the main thing here, that it is energy self-reliance. That means there is no need of depending on fossil fuels, as we are not depending on fossil fuels to generate this particular hydrogen. It is, a most important technique what we can make use for our entire applications. Now, if you again check the hydrogen demand worldwide, how it is moving starting from 2019 to 2070. So everywhere, refining, buildings, ammonia production, industry, power, transportation, everywhere, the demand is increasing day by day, year by year. And if you see in 2019, this particular hydrogen may be used only in industries as well as in refining processes. Whereas now, if you see by 2070, it can be used everywhere, starting from refining to transportation. Everywhere this particular hydrogen can be used as a fuel. That is the reason why the demand for hydrogen generation is increasing day by day. And now I just wanted to project what are all the traditional methods available in order to generate this particular hydrogen energy or producing the hydrogen. So we have basically 7 methods available. And the first one is steam methane. Methane is again combined with the water, and we will be making use of catalyst, and it is heated so that you will be having hydrogen. But if you observe here, there is again a production of carbon monoxide, CO is emitting. And the second one also, if you see partial oxidation, here again methane is mixed with oxygen and it is heated. Again, the production will be carbon monoxide along with the hydrogen. So these are all the traditional methods we have for generating this particular hydrogen. So these are the 7 techniques we are having. If you see all the equations which are given over here, there is an equal amount of carbon dioxide or carbon monoxide releasing along with this particular hydrogen in all the 7 methods, whatever I have indicated. Maybe in the last method, carbon is there, but it is in a solid form. Again, that is a waste, which is not needed for us. So now how we can avoid this particular emission of carbon monoxide or carbon dioxide while generating this particular hydrogen? So that has given an idea of the next advanced methods of generating hydrogen. So what the challenge is, what I told you just now here is, we have carbon emissions and also we have resource dependence. The methods what I have given in the previous 2 slides, the heating purpose or whatever we are having, everything is done based on fossil fuels. Fossil fuels are used either for electrolysis process or heating purpose, whatever it may be, fossil fuels are used. Because of the usage of this particular fossil fuels in the generation of hydrogen, we have carbon monoxide as well as carbon dioxide as byproducts, which are harmful gases and which are changing the climatic conditions. So that is the reason why we are thinking of new technologies, what we can have for the generation of this particular hydrogen. So here are the few advanced methods of generating hydrogen. So the first method could be electrolysis of water. Again, when I say electrolysis, anode and cathode will be there again. So, but the energy which is used for this particular electrolysis process is derived from the renewable sources like your solar, wind, or hydropower, whatever it may be. where you will not be having any carbon dioxide or carbon monoxide as byproducts. So this is the list which is given here. Anyhow, I'm going to deal with individual ones in detail. So these are the methods available to develop, to have the hydrogen energy as production. So again, while generating the hydrogen, based on the sources, whatever we are using, there are different types of hydrogens can be generated. So if I make use coal as a source, then the hydrogen is called as black or brown hydrogen. If I make use of natural gas like methane, ethane, acetylene, whatever we are having, so here it will be green hydrogen called as. And if I make use of fossil fuels, then like coal and everything, it is called as blue hydrogen. And finally, if I make use of renewable energy, right, then it is called as green hydrogen. So our present trend in generating this particular hydrogen, in producing the hydrogen, is usage of this particular renewable energy technologies, so that we can have green hydrogen. Why I'm calling this specifically as green hydrogen means there is zero emission of your carbon monoxide as well as carbon dioxide. So that's why we are calling it as a green hydrogen. And now what is exactly green hydrogen? So green hydrogen, it is produced using renewable energy powered electrolysis, and it offers a sustainable emissions-free alternative to traditional hydrogen production methods, what I have shown just now. And what are the steps involved in generating this particular green hydrogen? We have electrolysis process, and then we have renewable energy source for the electrolysis process, and we need water at the same time. We need electrolyzer, and then hydrogen conduction will be there. And then the final byproduct along with the hydrogen will be oxygen, which is very much needed for every living being on Earth. So as oxygen as a byproduct we are getting, we are saying this as a green hydrogen. Right, so this is the last step. After collecting hydrogen, we are relieving this particular oxygen into air. So now what is the benefits of this particular green hydrogen we are having? The first thing is renewable integration we are able to do successfully. And there is zero emissions we are having. That's why we are calling it as decarbonization. And we have diversified sources, reducing reliance on fossil fuels. As we are using renewable sources as the source, that reliance on fossil fuels can be reduced effectively. So this is the benefits what we are having. And if you see what is the environmental impact of green hydrogen. So if I go for this particular coal plants or whatever we are having in the generation of hydrogen, it will be carbonizing, like carbon emissions will be there. So if I make use of this particular green hydrogen through renewable sources, so I'll be having reduced emissions, because of which your air quality is improved. And finally, you will be having your climate mitigation. That means you are going to have a clear climate with the zero emissions, which is actually our main goal of the sustainable developments. So how sustainable hydrogen energy, how we can generate? Why I'm calling it as sustainable? Because it is not harmful and it can go for until the universe is there. Like it is sustainable. There is no never ending for this particular source availability. Hence, we are calling it as a sustainable hydrogen energy generation. Until the universe is there, you will be having this particular type of generation existence. So the first type of sustainable hydrogen energy generation is electrolysis of water. So we will be having a clean hydrogen from this particular type of method. And the second one is solar driven hydrogen production. We are making use of sunlight over here in order to produce the hydrogen. And we have biological hydrogen production. We have a lot of waste available now. So making use of that algae and bacteria, we can produce this particular hydrogen. And we have high temperature electrolysis. And here we will make use of heat and electricity to increase the efficiency of, this is also a type of electrolysis only, but instead of using only electricity, we are combining heat with electricity so that fast and efficient electrolysis process will happen. And then we have wind powered electrolysis. We are making use of wind energy as a source to generate the hydrogen, and biomass gasification, and which converts your biomass into hydrogen by heating it. And then we have methane pyrolysis, and clean hydrogen from methane with no carbon dioxide emissions can be obtained. I'll go in depth in next slides. And the next one is solar thermal hydrogen production. And then finally, we have waste to hydrogen. There are different types of waste existing. So that's why we have biomass classification and we have biological hydrogen production and then waste to hydrogen. Different wastes are used for different types of hydrogen productions. So now first I want to discuss about the electrolysis of water. Everybody is aware of what exactly electrolysis, but how far it is different over here. So here the electricity, what I am showcasing in the equation 2H2O is being divided into 2H2 and O2. The electricity, whatever I'm using here, this electricity is a DC power I'm using. And this DC power can be obtained from any of the renewable source, whether it could be solar or wind or biomass, whatever it may be. That energy, DC power, can be used for this particular electrolysis process. Anyhow, the oxygen is separated from hydrogen and oxygen is sent to air. And here hydrogen is again stored in your different types of storage systems, which we are going to discuss later. And now, what is solar driven hydrogen production? See, I hope the previous speakers might have given you what exactly the hydrogen production and how it is related to renewable energy, because few of the speakers have already discussed about it as per the schedule I have gone through. So I'm just giving a quick glance of what are all the different production methods we are having here. So this is a simple layout of solar driven hydrogen production we are having. So you will be having solar panels and from where power is collected and this power is sent to electrolyzer, and then your hydrogen compressor will be there, and the hydrogen which is developed here will be sent to hydrogen tank. This is a simplest structure whatever we are having, and this is the block diagram representation whatever we are having for this particular solar driven hydrogen production. And the next one is biological hydrogen production. And we have fermentation techniques available as well as photolysis techniques are also available. So this bihydrogen production has been done by making use of fermentation processes as well as biophotolysis processes. So again, under fermentation, we have photo fermentation, dark fermentation. Again, we are making use of light over here for photo fermentation as well as biophotolysis and indirect biophotolysis. And this is a simple structure of a biological hydrogen production we are having. So both dark fermentation also resulting in hydrogen as well as photo fermentation is also resulting in hydrogen over here. So the waste, whatever we are using will be especially food waste or the organic waste, what we are getting from some industries and all, food industries, whatever we are having, that can be used for this particular technique as a source. And the next one is high temperature electrolysis. As I already told you, along with the DC supply, whatever we are using, along with this particular DC supply, the temperature of this particular electrolyte has been raised to nearly 750 degrees to 950 degrees. This is the difference what we are having between the first method, what we have discussed, that is simple electrolysis process, whereas this is high temperature electrolysis process. This could be faster than the first technique. And next we have wind powered electrolysis. In place of solar, what we have seen the previous technique, we are making use of wind energy as a input. The DC power required for the electrolysis process has been driven from the wind power. And this is the block diagram, what we are having with this particular wind powered electrolysis. This is also same as your solar powered, but only thing is in place of solar, we are making use of the next type of renewable energy, that is wind power. And then biomass gasification we are having. So the biomass has been sent to gasifier. Again, it is heated by making use of steam. And there is also a byproduct over here, ash. And there will be a separator. And making use of all these setup, we are having gas cleanup as well as CO2 will be observed. And then finally, we will be having the H2 as our final product. And this is a typical plant structure we are having for the biomass gasification. Whatever the things discussed here in this particular block diagram, this is just a plant layout, simple plant layout we are having. And then methane pyrolysis. So this is the equation. Again, the methane is heated so that we will be having carbon and hydrogen as our products. So this is a carbon black. Maybe this can be used for some other industrial purposes also, this carbon black. And this is the processes involved in the pyrolysis. And finally, the product is hydrogen. I don't want to get into depth of this particular generations because these are all very simple techniques which everybody knows. The only thing is why we are calling this as green hydrogen generation. I just wanted to showcase because we are using all renewable sources over here. So that is the reason why we are calling this particular green hydrogen generation, as well as the sources what we are using are renewable. Hence, this is a sustainable generation also. And the next one is solar thermal hydrogen production we are having. Both the temperature of this particular output as well as solar power, both are used for the generation of this particular hydrogen. And then finally, waste to hydrogen. So we have again a gasification unit available. So green hydrogen as well as syngas are the, syngas is the byproduct when we go for this particular type of production. And this is the block diagram representation of the hydrogen production from solid waste. Now, if you look into the statistics again, because I have finished what are all the generation techniques are available for the hydrogen. So currently, how much is the hydrogen produced by different countries? If I want to have a look. So majorly, China is producing. This is in tons. And USA is in second place. Whereas our India, at 6 billion tons of hydrogen we are producing. And this is the statistics available. So we are in third place currently. So our, again, Atmanirbhar Bharat, the concepts of Narendra Modi ji, they want India to be in the first place in the production of this particular green hydrogen, not only in production, but also in storage also. And if we want to look only into the hydrogen market of India, so these are the statistics we are having. Currently, the market size is growing at a compound annual growth rate of 6.9% from 2022 to, and currently it's based on the last 2 years statistics, 2022 to 2024, they decided that the growth rate is 6.9%. So if we continue like this, by the year of 2032, so India hydrogen market size is expected to be very high. And it will hold a substantial share also by 2032. And these are the different green hydrogen projects and opportunities available in India. So we have demonstration projects available, and the investment is nearly 150 billion US dollars they have done for this demonstration projects. And we have National Hydrogen Mission. I think the first day, second session was based on this particular MNRE, what are all the green energy missions we are having by our Narendra Modi ji. So they announced a budget also for this, and they have made some policies also to have this particular hydrogen generation and storage. And currently we have 16 plants running, and there are 6 major plants are in pipeline. And again, $80 billion were used. And this 111 mission is made by Reliance. They wanted to have the cost of this particular hydrogen production as $1 per kilogram. So that's why they made it as 111 machine. So Reliance has committed to this. So they have invested again $80 billion on this. So the plants were majorly by Reliance only. Few others are also involved, but majorly Reliance is taking care of this particular 111 mission. And also we have mobility provider, that is Sustainable Future Mobility. All of our focus is on fuel cells, and major OEMs and Infrapla are involved in development activities. And we all know currently we are thinking of e-mobility. So most of the combustion engines have to be replaced with our electric motors, so that the carbon emissions will be less. And as e-mobility is a trending era for us, now there are also so many projects involved in this particular hydrogen projects, and we can make use of hydrogen fuel cells as our e-mobility resources. And there are 18 research institutions which are seriously working on this particular green hydrogen projects. Like R&Ds are being happening. Recently in May 2024, there is a book released by them also. So what developments we can have with this particular hydrogen projects, what are all the new opportunities we are having. So it is released by MNRE, Ministry of New and Renewable Energy Development. And again, what is the installation capacity where we can have this particular green hydrogen of India? If you look into the green areas, whichever are having over here, these are the locations we have in Karnataka, Kerala, Tamil Nadu, Andhra Pradesh, Odisha, West Bengal. Everywhere we have this particular green hydrogen capacity installation. And the government has held initial talks. Now, maybe in another 2-3 years, they may start. And the production cost, if I see now, if I make use of coal, hydrogen can be produced, but it is in brown energy, I said, brown or blue energy we are having. So it is costing $8 per kg. Whereas if I go for renewable, it is costing much. So that is the reason why the process of erection of this particular green hydrogen sustainable plants is a bit slow, because the initial cost is high. It is taking $47.6 per kg generation of hydrogen. So now application of green hydrogen, I already told you, we can make use of in transportation, and we can make use of in industry as well as in energy storage also. And it is also used in industries. The special specific applications of green hydrogen could be in steel production, chemical manufacturing, refining, fertilizer production. And also we can make use this for our transportation sector. So that means we can make use in fuel cells and heavy duty vehicles, maritime and aviation, as well as refueling infrastructure, public transportation, collaborative initiatives. These are all the applications where we can have this particular green hydrogen. And green hydrogen in power generation can also be used. Fuel for gas turbines or fuel cells, energy storage. Now, what are all the key challenges we are having in this particular hydrogen energy generation? So first thing, high production costs. Just now I showcased a graph which is indicating how much is the cost, US dollars we are having if we want to have this particular hydrogen production. Nearly $47 we need to spend in order to generate 1 kg of hydrogen. So the production cost is very high. That's why the process is being delayed compared to fossil fuels. I'm comparing with fossil fuels, the production cost is more. As well as energy efficiency, hydrogen generation, storage and conversion processes, they result in energy losses, whereas reducing overall efficiency. And storage and distribution, this is the main challenge where we can store this particular hydrogen and how we can move hydrogen from one place to another place. This is again a big deal we need to think about, and this is a good research area, how we can store and distribute this particular hydrogen. It is a challenge now. And then production emissions. If I go with natural gas as well as some other techniques we are having, so you have a gray hydrogen production. So where again you will be having the CO2 emission. So we need to think of it again, how we can eliminate this particular CO2 production. And scalability. So many clean hydrogen production technologies are still in development and face challenges in scaling up for mass production. The main reason could be the high production cost only. So if that cost can be reduced, as Reliance has decided that 111 machine. So a lot of R&D is happening in this. So if they can thought of any new technique in developing this particular hydrogen production, so then maybe you can scale up for larger productions of hydrogen. And then renewable energy supply is again a key challenge. So hydrogen production depends on intermittent renewable energy requiring reliable storage solutions. Again, when I say I'm using the renewable energy as a source for the electrolysis process and all, so the renewable energy directly may not be used. Again, we need a storage system for that. Storage again for storage, as well as production, storage for production. These two are the main challenges we are having. And then market viability. Hydrogen must compete with other clean energy sources, and its adoption requires policy support and investment. Just like already we have the electric vehicles, there is no registration required like that. We have so many rules and regulations formed by our governments so that more electric vehicles can come into picture. So such type of any policy support will be given by our government, then definitely the generation of this particular hydrogen will be more. And public perception. Main thing, when we talk about any gas, the first and foremost fear what the public is having is its safety. So if we can prove that the hydrogen transportation as well as generation is safer as like the other generation techniques, then obviously this adoption will come for the generation of this particular hydrogen. So environmental impact. So large scale hydrogen production could impact land use, resources and ecosystems. So people may not be ready to have a plant of this particular hydrogen plants. So we need to get permissions also for that. So that permission could be from government or from the landlord, whatever we are having. So maybe again, that could be a challenge we are having. It may not be a big challenge, but it also counts in one of the challenges for the production of hydrogen energy. And we have long-term sustainability again. So achieving full sustainability in hydrogen production and use requires advances in technology and circular economy practices. So whether we can sustain this particular plants, whatever we are erecting as well as what we are maintaining now, if we can have the long-term sustainability of it, again, we can have better hydrogen energy generation. So as I heard that somebody have already told about this particular National Green Hydrogen Mission. So it is made by our government of India. So the overarching objective is to make India the global hub for production, usage and export of green hydrogen and its derivatives. And this will contribute to India's aim to become Atmanirbhar through clean energy and serve as an inspiration for the global clean energy transition. So the mission will lead to significant decarbonization. Ultimately, our main aim is that only, decarbonization, so that the climatic action will be good and we have a green, sustainable climate available for everybody. And these are the outcomes currently what we have with our green hydrogen mission. So we have 5 million tons of green hydrogen by 2030, mega million tons of green hydrogen by 2030, and 6 lakh new green jobs will be there, and 60 to 100 gigawatts of electrolyzer installations are going to happen, and we have 125 gigawatt renewable energy for green hydrogen production, and over 8 lakh crore investments will be there, and 50 mega million tons of carbon abatement cumulatively. And these are the strategic interventions for green hydrogen transition. And we have targeted sectors for pilot projects, long range heavy mobility, port and shipping, steel, biomass to hydrogen, and the key enablers. So what are the resources we are having, and what is the R&D happening in India, especially ease of doing business as well as public awareness, regulations and standards, infrastructure and supply chain. So these are the key enablers. I can say these are the key factors which are deciding whether our production of hydrogen can be increased by 2032 or not. So every area is very important to us, whether the resources abundantly available or not. Any R&D is happening in this particular sector so that new technologies are coming to have maximum hydrogen generation, as well as business is happening. See, if we generate excess of hydrogen, what we can do with that, whether we are able to export it or not. So that is also another reason. So ease of doing business, as well as what is the infrastructure necessities we are having, how we can build good infrastructure for the development of this particular hydrogen plants, and what regulations and standards. See, we have regulations and standards set by each and every energy sector. There are energy regulation policies available, ERPs. So similarly, there are some ERPs have to be set to have this particular hydrogen production. And mainly public need to be aware of this particular hydrogen generation, that they need to finally say that it is not harmful, whether the generation or transmission or usage of this particular hydrogen will never harm the public. That type of opinion we need to create. So now, what is the main thing once you generate this particular hydrogen energy? So after generating the hydrogen energy, the question comes whether the total generated hydrogen energy is being utilized or not. If it is not utilized, then what we have to do? Again, the question comes storage. And not only that, if we have more number of hydrogen plants are available and they are sustainable developments, that means their sources are renewable energies. So if we are making use of renewable energy generation clubbed for this particular hydrogen energy production, then what grid balancing we are doing? Are we capable of balancing the grid? Because every generation ultimately has to connect to the grid. So this renewable integration and the grid balancing are the main challenges, again, I wanted to say, along with the storage of this particular hydrogen. So what is hydrogen storage actually? Where this particular hydrogen storage we can have? So the main energy storage market segments could be, first thing is utility or industrial applications, including grid reinforcement, renewable integration, and uninterruptible power supply applications, whatever we are having. And the next comes transport or mobile applications, including onboard power for vehicles, new drive trains, as well as leisure applications. And finally, portable applications, including computing, cell phones, and cameras. Everywhere we can make use of this particular hydrogen. Now, what are the generic storage systems available to store this particular hydrogen? So the first one could be electrochemical systems like batteries and flow cells. And the second one is mechanical systems, where we have flywheels and compressed air energy storage systems. And we have electrical systems like supercapacitors and superconducting magnetic energy storage systems. Maybe the batteries and flow cells can store the hydrogen for a longer duration, whereas the supercapacitors, what we are having now, those are all instant energy discharge and charging applications. We can have that. And chemical systems, hydrogen cycle like electrolysis, storage, power conversion, and thermal systems where sensible heat and phase change we are having. So currently, these are the storage methods available for hydrogen. We can make use of steel cylinder, composite cylinder. Somebody, please mute.
Please continue.
ma'am.
So these are the hydrogen storage methods available. And the capacity is in watt-hour per kg. This is 12,000 watt-hour per kg also we can have. But mostly the storage method is in term of carbon nanofibers. So we all know that currently nanotechnology is playing an important role in every sector. So even in hydrogen storage method also, we can have this particular nanofibers where we can store in the form of carbon nanofibers. So with this nano carbon fibers, we can have the storage capacity about 10,000 watt-hour per kg. And now what are the key challenges we are having in hydrogen energy storage? So first question comes, what is the first challenge we have to overcome is low energy density by volume. As I told you in the beginning, if I take one bottle of petrol and one bottle of hydrogen of equal amounts, then maybe your energy density of hydrogen is low, but the energy efficiency may be reducing. But per mass, if I consider, it will be having good energy efficiency. So I need to increase the size of the containers where I can store this particular hydrogen. So that's why this is the first challenge we are having. Hydrogen requires large storage volumes or high pressure, low temperature. When I increase the storage volume, obviously the pressure of that particular storage system will increase. So the low temperature condition I need to maintain then. If the pressure increases, obviously the temperature also rises. So under such situations, I need to take care of this particular temperature of that particular container. Hence, this is the major key challenge we are having in storing this particular hydrogen in containers especially. Now, high storage pressure requirements. So if I want to compress the hydrogen and if I want to store it, again, there is a challenge involved in it. That means it requires, it could be costly, and the storage tanks capable of handling high pressures need to be again manufactured. So at low pressure, at low temperature conditions, if I want to store, the container size will increase. The storage volume will be increasing. If I want to store at high temperatures, it will be expensive, because the container tanks what we are using, the container we are using should handle that particular high pressure. So these are the two important key challenges I'll consider as a priority. And now cryogenic storage. So I can liquefy this particular hydrogen. And again, if I liquefy the hydrogen, we all know what is the losses we will be having, because it leads to energy losses through boil off. There will be boil off points existing. So cryogenic storage means the process of keeping substances at extremely low temperatures, that is less than 150 degrees centigrade. So if I go for such type of low temperature storage systems, again, you will be having the containers, what we are designing for that need to be modified, again, which will be costly. And also they are energy intensive. And then material challenges. So for the above three, whether the container consists of low energy density by volume or high storage pressure or cryogenic storage, the material challenges will be there, because hydrogen makes the container material brittle, and there will be wear and tear, so that there will be leakage from that particular storage tanks. So obviously the material which is used for that particular storage containers should have a property of embrittlement, like they should not have any wear and tear. So hydrogen embrittlement can weaken materials, making storage tanks and pipelines vulnerable to failure. So we need to take care of that particular corrosion or wear and tear because of the hydrogen, because it can easily mix with any type of, it can react with any type of other atoms. So whether it could be made of iron or aluminum or whatever it may be, the tanks, it will easily mixes it, and there will be a chances of corrosion, as well as there will be chances of wear and tear of that particular containers. So material will be again a challenge. And any chemical engineer are there, or if the electrical engineers are interested in this particular concept, again, it will be a good research area. What type of material can be used for hydrogen storage system? And then efficiency losses. So compression and liquefaction process which we are using for storing this particular hydrogen, they consume substantial energy again. So it may again reduce the efficiency of the storage system, because if we are unable to directly store the hydrogen in its gaseous form, and we are trying to either increase the pressure of it or reduce the temperature of it, it will again rises to the loss. And then high cost. So hydrogen storage systems are expensive to develop and maintain, hindering large scale adoption. See, if the plant output is less, the hydrogen storage will be at lower cost. But if we want to have more hydrogen production, obviously the hydrogen storage systems are also need to be large. And if we go for larger scale adoptions, then obviously it will be expensive. The cost for developing and designing the hydrogen storage system itself will be high. And main thing, safety concerns, as I already, everybody knows that hydrogen is highly inflammable. So the risk of leaks, it may be posing the safety challenges. So every time there need to be a strict check when we are transporting this particular hydrogen or when we are storing this particular hydrogen. So this flammability of hydrogen is again a safety concern to everybody. And now lack of standardization. This anyhow, we are saying that government is going to form policies and regulations. So if that policies and regulations are there, once with hydrogen's generation, storage and transportation, maybe the standardization, lack of standardization will not be there. Here, what I said is the absence of global standards for hydrogen storage complicates integration and adoption. But once we have the rules and safety rules and regulations, obviously we can overcome this particular problem, standardization problem. And we have infrastructure development. This is again another key challenge. So building the required infrastructure for large scale hydrogen storage is costly, just now I told you, because the material itself, what we are using for hydrogen storage is costly. So the infrastructure development itself is costly hence.
Ma'am, Logit,
Ma'am, please continue.
Okay, sir. And finally, we have integration with energy systems. So efficiently integrating hydro storage with renewable energy sources. And here we need advanced technologies for the energy management system. So this is the last key challenge, whatever we are having. As I already told you, if we are able to make use of metal hydrides, like the nanohydrides, whatever I told in the previous graph, if the hydrogen can be converted that into hydrides, then obviously the storage problem can be avoided. But converting the gaseous hydrogen into that particular hydrides itself is costly. So that is the main challenge what I consider when it comes to hydrogen energy storage. Still, how much time is there, sir? So finally, I just want to conclude. So hydrogen energy offers a sustainable pathway to decarbonization, providing clean energy solutions for transportation, industry, and grid integration, driving the transition towards a low carbon future. And though it has immense potential as a clean energy, we need to think of the cost, efficiency, infrastructure development, and the environmental impact of its production processes. And if we can have continuous technological advancements, policy supports, as I already told you, and investment, hydrogen could play a significant role in achieving global climate goals and transitioning to a sustainable energy future. So our ultimate goal of climate action can be achieved through this particular generation of hydrogen energy. I just wanted to show you like what are all the policies made by, this is the Indian government site, National Green Hydrogen Mission we are having. So why they are playing an important role and all. And also this is the Ministry of New and Renewable Energy. See, being electrical engineers, we always go through what are all the policies and rules and regulations are set up by our government. And we need to go through this particular websites regularly so that what are all the updations we are having, we will come to know. And this is National Single Window System. So Green Hydrogen Mission, how they are achieving it is clearly given over here. Everything is our government websites only. So I took most of the information from this particular government websites only. So I request all electrical engineers to go through this particular websites regularly so that we can know what are all the research topics available, what areas we can go for or we can consider for research. Sir, Sharvanan sir.
ma'am. Yes, ma'am. Please.
From my end, I am done with.
Okay, ma'am. Please, ma'am.
If anybody have any queries, I'm happy to.
Participant, this is your time. Anybody is having a query, please. I think. Okay. Sir, Sivaganesen sir.
Yes, sir.
Sir, please.
Okay. Good evening, everyone. It's my privilege and honor to deliver the vote of thanks as we conclude this FTP on hydrogen energy production and storage challenges. I extend our gratitude to our esteemed speaker, Dr. Radhika Dora, for gracing this program with your presence and sharing your invaluable insights. To our participants, I extend my gratitude for your active engagement throughout the session. As we conclude, let us carry forward the experience and inspirations gained from this FTP and continue to work collectively towards enhancing engineering education and research. Thank you all for being the part of this journey. Wishing you all the very best for your future endeavors. Thank you.
Thank you, sir. I thank all the participants for their patience listening. Maybe my presentation may not be that much worthful, but I try to give you insight.
Very nice, ma'am. Okay.
The next
Very
time,
good.
because this is the first time, frankly speaking, delivering a lecture online to so many participants. And I'm very glad, once again, I'm thanking Holy Mary as well as AICT for giving me this opportunity.
You presented
And I
in a
thank
nice
all the
way.
participants for their patience listening.
Ma'am, you presented in a nice way, ma'am. It will be very informative and useful only, ma'am.
Thank you, sir. Thank you.
Thank you, ma'am.
Thank you.
This is excellent presentation, madam.
Thank you, sir.
From participant side,
Anyone want to speak? Saravanan sir, shall we conclude? Can I stop the recording?
okay, sir, once I check our HOD will be there or not. 1 minute, sir.
Ramapu sir?
Yes, sir. Good evening. I'm there, sir.
Sir, please,
Yeah,
sir.
yeah. Ma'am, good evening, ma'am.
please.
Yeah, okay, sir. Good evening, ma'am. It is a wonderful
evening,
session, ma'am.
Thank you, sir.
Wonderful session. Thank you very much for your efforts to give a wonderful knowledge regarding trends in the battery systems and hydrogen system, everything. Thank you very much, ma'am. And thank you very
Thank
much,
you,
and participants, respected participants, who are giving continuous encouragement and support. Thank you once again. Good night, all of you. And sir, Professor Saravanan sir and Sivaganethan sir, you organized wonderful session. This session is very
Thank you, sir.
nice, sir. Thank you, sir. Thank you very much. Ma'am, once
Thank you
again,
for your
thank you. Thank you very much, ma'am.
Thank you, sir. Thank you.
With our management and our support only we are doing, sir. Thank you.
Sir,
Because
thank you
of
so
you.
much, sir. Thank you. Thank you, sir. Thank you, sir.
Okay, sir. Shall we stop
Okay,
recording? Okay.
Yes, sir.
right, okay.
Sure.